On July 1st, 2025, astronomers in Chile detected something moving through our solar system that shouldn't be there. Not a rock from the asteroid belt, not a comet from the Kuiper belt. This was 3I Atlas, the third confirmed visitor from interstellar space. And when scientists analyzed its chemical signature, they found something they'd never seen before. A comet that breaks nearly every rule we thought we understood. This is the real story of the most chemically bizarre object ever to pass through our neighborhood. Interstellar objects are vanishingly rare. In all of human history, we've only confirmed 3. The first was Oumuamua in 2017, that strange elongated visitor that sparked endless debates about whether it could be artificial. The second was 2I Borisov in 2019, which behaved exactly like we'd expect a comet to behave, giving us a reassuring glimpse of a normal interstellar traveler. Then came 3I Atlas. Discovered by the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Chile, this comet immediately stood out. Not because of conspiracy theories or government cover-ups, but because its chemistry is genuinely scientifically bizarre. Here's what makes an interstellar object so important. These are the only samples we can study from other star systems without traveling light years to get there. When something crosses into our solar system from interstellar space, it carries a chemical fingerprint from wherever it was born. A distant stellar nursery with different conditions, different temperatures, and different radiation environments than our own sun produced. 3I Atlas appeared to have formed in what astronomers call the thick disk of the Milky Way, a region populated by older, metal-rich stars. And the chemistry is showing us it's unlike anything we've ever measured in a comet before. Let me be clear up front. There were rumors online about sealed data and embargoes until 2099. Those claims are misleading. What actually happened is more interesting than a conspiracy. It's about how science works in real time, how data gets processed, and what happens when an object genuinely surprises the people studying it. Here's the moment that made scientists stop and recalculate everything. When they measured the nickel-to-iron ratio in 3I Atlas's coma, it didn't match any comet in our solar system, not even close. In our solar system, comets have predictable ratios because they all formed from the same protoplanetary disk around our Sun. The elements were mixed in specific proportions 4.6 billion years ago. And that signature is stamped into every rock, every asteroid, every comet we've ever studied. 3I Atlas has a different stamp, and that means it came from somewhere that formed under fundamentally different conditions. Let's talk about what that actually means. When astronomers first began observing 3I Atlas in detail, they expected to see water vapor, carbon monoxide, maybe some dust, the standard ingredients of a comet. What they got instead was a composition that flipped their expectations. The comet is losing about 150 kilograms of mass every second. But here's the strange part. Only about 4% of that is water. The rest, about 87%, is carbon dioxide. 9% is carbon monoxide, with traces of other compounds. That's backwards from what we normally see. Most comets in our solar system are water ice dominated. When they heat up near the sun, water vapor is the primary emission. But 3I Atlas is dominated by carbon dioxide, and it's sublimating at an extraordinary rate while still relatively far from the sun. Then there's the hydrogen cyanide. Yes, HCN, the same compound famous for being toxic to humans, has been detected in its emissions. Now, before anyone panics, hydrogen cyanide is actually common in comets. It's a key molecule in prebiotic chemistry, one of the building blocks that, under the right conditions, can lead to amino acids and eventually to life. Finding it in a comet isn't unusual. What is unusual is the overall chemical cocktail. The ratios are off. The real bombshell came from spectroscopic analysis. 3I Atlas shows nickel emission lines without corresponding iron lines. In our solar system, nickel and iron are cosmically paired. They form together in supernova explosions, and they're found together in predictable ratios in asteroids, meteorites, and comets. But not here. This suggests that 3I Atlas formed in a stellar environment with a different elemental abundance pattern. likely around an older, more metal-rich star than our Sun. That makes it a messenger from a completely different chemical epoch of the galaxy. Scientists believe 3I Atlas originated in the thick disk of the Milky Way. This isn't science fiction, it's galactic geography. Our galaxy has several structural components. The thin disk where our Sun lives, the thick disk populated by older stars, and the halo. The thick disk formed earlier in the galaxy's history, when there was more turbulence, more stellar collisions, and stars had higher metallicity, because previous generations had already enriched the interstellar medium with heavy elements. If 3I Atlas formed in that environment, its ice would have condensed under different conditions. The radiation environment would have been harsher. The available elements would have been in different proportions. The volatiles trapped in its ice would reflect that ancient chemistry. That's what we're seeing, a 4 billion-year-old time capsule from a region of the galaxy we can't visit, carrying chemistry from stellar nurseries that no longer exist in the same form. In early October 2025, 3I Atlas made its closest approach to Mars. The European Space Agency's ExoMars Trace Gas Orbiter and Mars Express were perfectly positioned to observe it from about 30 million kilometers away. This was a huge opportunity. Ground-based telescopes have limitations: atmospheric interference, light pollution, and the sheer distance involved. But having spacecraft in Mars orbit meant high-resolution spectroscopy, direct imaging, and the chance to study the comet's coma in detail without Earth's atmosphere getting in the way. The observations were made, data was collected, and here's where the confusion started. Online, rumors spread that ESA had sealed the data until 2099, a 74-year embargo, suggesting some kind of cover-up. The truth is more mundane, but reveals something important about how scientific data actually works. The 2099-0101 date that appeared on some file listings is an automatic placeholder used in ESA's archive system when raw data files haven't been validated yet. It's not a real release date, it's essentially the database equivalent of TBD. ESA follows an open data policy where scientific data is typically embargoed for 6 to 12 months to allow the observing teams to analyze and publish their findings first. This is standard practice across space agencies. It prevents situations where the scientists who designed the instruments and observation campaigns get scooped by others before they can even process their own data. Some raw sensor files were embargoed until April 2026, about 6 months after the flyby. That's completely normal. But here's what's important. NASA released processed images and data from 3I Atlas on November 19, 2025. The scientific community is actively studying this object. Papers are being written. Data is being shared. The conspiracy was really just a misunderstanding of database placeholders and standard scientific protocols. At a press briefing, NASA officials directly addressed the rumors. Their conclusion: 3I Atlas behaves exactly like a natural comet. There are no technosignatures, no signs of artificial structures, no evidence of anything other than a chemically unusual but entirely natural object. And chemically unusual doesn't mean alien spacecraft. It means we're seeing comet chemistry from a different stellar environment for the first time, which is exactly what we'd hoped to see from an interstellar visitor. Every interstellar object we detect teaches us something fundamental about the galaxy. With only 3 confirmed visitors, each one is precious. Oumuamua was too small and too fast. We couldn't study it in detail before it left. 2I Borisov was wonderful for being normal. It confirmed our models work. But 3I Atlas, it's the Goldilocks case. Close enough to study in detail, unusual enough to challenge our assumptions, but still scientifically explainable. It tells us that the formation of comets around other stars produces different chemistry. It confirms that the thick disk of the galaxy has a different elemental fingerprint than our local neighborhood. It gives us a direct sample of ancient stellar environments without requiring interstellar travel. And perhaps most importantly, It reminds us that the universe is more diverse than our local sample suggests. Our solar system is one data point. Every interstellar visitor expands our understanding of what's possible. The real story of 3i Atlas isn't about government cover-ups or sealed secrets. It's about the messy, complicated, fascinating process of studying something genuinely new. Scientists had to build new models to explain the carbon dioxide dominance. They had to reconsider comet formation theories to account for the nickel-iron anomaly. They had to coordinate observations across multiple spacecraft, ground telescopes and research teams, all while the object was racing through the inner solar system. And yes, there were database glitches, data processing delays, and the inevitable confusion that happens when automatic placeholders get mistaken for embargo dates. That's not a conspiracy. That's just how real science works in real time. What we're left with is something more valuable than any conspiracy theory. A genuine scientific mystery with a natural explanation. A visitor from an ancient corner of the galaxy carrying chemistry that broadens our understanding of how diverse planetary systems can be. 3i Atlas came, showed us something we'd never seen, and continued on its journey. The data is being analyzed. Papers are being published. Our understanding is evolving. That's how discovery actually happens. If you're interested in the real science behind interstellar objects, comets, and what we're actually learning about the galaxy beyond our solar system, subscribe to the channel. We focus on what the evidence actually shows, not what makes the best clickbait. Share this with someone who's curious about astronomy, but wants facts, not fiction. Because the universe is strange enough without needing to invent mysteries. And if you want to dive deeper into the chemistry, the observations, or the actual scientific papers being published about 3i Atlas, I'll put the links in the description. The cosmos is full of real wonders. Let's explore them together.